This conference will now be recorded.
Anyone? Any volunteers?
Well, I think we need to validate the application, like how the
Uma,
application is
your voice
behaving.
is breaking actually. Is it from only for me or for everyone?
It's for everyone, I guess.
Right, right, yeah.
We need
Performance
to
testing.
test the performance of the how the application is behaving under different conditions of load.
Okay, right. I couldn't hear it fully, but I think I heard about the word load. Uh, that's good. Charan, can you go ahead with the answer?
Yeah, so testing, the purpose of performance testing is to measure the performance of various applications. It could be a web application or a database
Hmm.
or
Mm-hmm.
any
Yeah.
application to under stress or
So,
load,
okay.
like
So let me put it this way. So when we say performance, what is it that we are looking into? So performance in what way, right? So what is it?
so performance, like how the application reacts when
Mm-hmm.
let's say if there are 100 users who are logging in and try to
Mm-hmm.
access a login to Amazon page or some other website,
Okay.
how the performance
Mm-hmm.
how the application will react to it, like if there are 100 users or 1,000 users, or let's say during Diwali season or something, we are
Right, right.
you are doing
Okay.
retail.
So let me pick up that word keyword users. Okay. That's the keyword I got from your answer. Any more answers? Anyone?
Yeah, so uh, the first, I guess, when we see the number of
Yeah.
users ramping up for the particular website and how
Mm-hmm.
your application is behaving for that
Okay.
number of users. So behavior is very important when we
Mm-hmm.
go for
Right.
the performance test.
So I will just put it this way, behavior of, or I can say behavior rather than behavior. Let me put it this way. Maybe some, uh, okay, how the, let's say some fluctuations. Okay. So when I say fluctuations, fluctuations in what? What is a measurable quantity?
Fluctuation in the sense that belongs to a response time.
Okay, let's say there is one response time. Anything else which will fluctuate?
Availability.
Uh,
I will not
data,
bring that word availability
some
here because that's a separate sort of totally different word. Okay.
Your infrastructure
Rather than,
utilization.
yeah.
Directions.
So I will put it this way: fluctuations uh, the number of requests, or I will not use the word request now because it might be new to you all, or I will use the word. Let's say you have an application like some x.com, okay, and you are reloading it or loading it, okay. Now 100 people are reloading it, okay. So okay, 100 are reloading, so at 1 second it will be 100, at 2 second it will be 50, at 3 second it is 120. So what is happening here is, though every time the reloads is 100, we have kept it constant at 100, but each time the real reload that is happening is fluctuating between. Are you getting my point? So what is happening here is, in this case, so 100 people are reloading the application, let's say, okay, reloading that x.com, okay. So at 1 second there were 100 reloads, okay. At 2 second there were 150 or 120 reloads, okay. And here what happened, the reload dipped to 50, okay, then again it went to 130, okay. But every time I am trying to reload 100 only. That's what I am trying to do, but my application is doing this. Okay, so there is a fluctuation in the number of again let's say reloads I will use here. the word. Then I will not go to the word request now because I need to come to some point before that. So what is happening now? Now let's say there is one another application. Okay. Now there is one another application for which the same activity I'm doing. Let's say it is y.com. Okay. I'm doing, and the graph looks something like this at 1, 2, 3, 4, and let's say the graph, this is 100 and this is 100, 120, and this is 0. Okay, so what's the difference between both of these graphs, graph A and graph B?
Graph is not in steady state, like it is up and down, like
Mhm.
not in even condition.
Yeah,
Graph
so
B
I
shows
will
like
say this
maintaining
is
the
not very
maintaining the
smooth.
stability.
Okay, not smooth. Okay, and this is very smooth.
Yeah.
Okay, right? So what type of application will you like, A or B?
Yeah.
B.
P, right? The thing is, see now, so at some point I am able to go to 150, 130, but at some point I am at 50, okay, which is not a good sign, because though at some point I am able to go to 120, 130, sometime I am only 50, which is not good, because 100 people are trying to reload and only 50 people are actually getting the reload. Others are waiting for the, like, at the 4th second only their reload is happening, which is not good, right? But here what is happening, at every second or at every time these 100 reloads are happening properly without any much fluctuation. Now this is a very ideal case, generally you will not find this, but just to comparison. Okay, now so what is happening here is, between A and B we choose A because we choose B because it is, I will use a word called more stable. Can I say that? Can I say that B is more stable? Right? So that's where the first word comes into picture, which is called the stability. So in performance, we test whether my application is stable and at different various number of users or loads, okay, which you get as an SLA from your customer or client, which we will discuss what these are, okay, what those diagrams are. But anyways, so stability is what is the first key point indicator of a performance. Like when you are testing any application, stability is the KPI. Okay. So what is the direct metric? Okay, or what is a quantifying metric which will show the stability of the application? Anyone?
Uh, s-
Constant throughput.
the average response time
Graph.
and the through.
Okay, right. So what I will do now is I will plot a graph. Okay. Now here, let's say I use like again the word number of requests. Okay, requests are nothing but, just assume like you have a website like x.com, and you are opening that x.com multiple times. Okay, like one time, two times. So if it is two times you're opening, like you are not opening it two times, two users are opening it, then you say two requests have been sent to x.com. Or if three users are using, three requests have gone, just in a high level way I'm saying. Okay, just assume like that. These are number of requests in the y-axis, and you have time. So let's say 1 second, again 5 seconds, 10 seconds, 15 seconds. Okay. Now let's say this application x.com. Let's say 10 users are using now. Okay. And I am plotting the graph. Like at 1 second, how many requests were there in x.com, and so I'm just plotting that graph. Okay. Now if that graph is something like this, okay, we say our application is not that stable. Okay, now why I say the application is not that stable, because see, let's say this high point is 5, and let's say this one is 3, and let's say the median is 1. Okay, and 1 is what we are expecting, let's say. When 10 users are using x.com, okay, let's say 10, 30, 50, okay, 10 is what we are expecting, but we are getting sometime 30, sometime 50, sometime it is totally going down to, let's say, 1. Okay, so that's what we are observing. Now, can anyone say why it is going to 50 at some time? Because we have only 10 users. How can it go to 50? Why is it going to 50? Anyone? If 10 users are opening x.com, logically I can say it is 10. But how can it go to 50 at some point? Anyone?
Vishnu, come again. What is the question now?
Right. So see, there are 10 users who are opening
Hmm.
x.com. Okay. And
Okay.
let's say to open that x.com, it takes 1 second. Okay. For one user.
Okay.
So for 10
Hmm.
users, so basically 10 at 1 second, all the 10 requests would have been completed. Right. But why at, let's say at some points you are getting 50 seconds? Why? No, I mean, not 50 seconds, 50 as the value, the number of requests.
Server is not responding.
One way, because see, now this 1 second, think if it becomes 5 seconds, right? What is happening? The response time is increasing, okay, due to some reason, and that's why what is happening? The number of people waiting increases. Okay, so and that gets built up, and at this point there are 50 users waiting, okay, to complete that site accessing. So that's what this 50, and here it is 10. So this shows that your application is not stable, because if it was stable, it would have maintained that proper response time of 1 second, and it would have constantly been smooth at a linear in a linear way. Okay, now, so this thing what you have here is called the throughput. So what we do is, throughput is nothing but simple. So you have a graph, you have number of requests, okay, and here it is a time. So let's say the time is in seconds, okay, which what I'm doing, and we have the number of requests like uh, 1 2, okay, and let's say my graph is like this, just an ideal case. So it's always 2, okay, 2 2 2 2, okay, at 1 second, at 5 seconds, at 10 seconds, at 15 seconds, every time it is 2. So I say my throughput is 2 requests per second. Now this is the average which I am saying. Average. Now here the average will remain same because it's all same only. Okay. But if you have some graph which is looking like this, something like this, then you will have to take the average. Like for example, if it is 3, then if it is here 4, not 4, if it is 1 here and again 3 here. So you have to take the average of this to get this value. So this value which you get, right, the number of requests to time, or we can say the number of requests which is going to the server per second or per time. So what do we mean by 2 requests per second? What do I mean by that? Like if I say my application can take 2 requests per second, what do I mean by that?
So that will be two transactions, right?
We will come to that. Okay, so request and transactions are two different things, and most of the time they are same, but not always. Okay, so that's why I specifically pointed out now the request word. Okay, so request and transaction and hits, all three are different things, but they merge also. Like for example, request can be transactions, hits can be transactions, but not always. There are situations where these change. Okay, but anyways, coming to request, I'm not bringing these words now. We will soon see what they are. So when I say 2 requests per second, let's say on x.com, what it means is my x.com can be opened twice in 1 second. Can I say that? Everyone, hello?
So which means that user actions, right? In 1 second. That's what you mean. A particular
Okay, so
functionality.
let's put it this way. Let's say I have 100 users. Okay, let's say I have 10 users. Okay, and they are opening x.com. Okay, uh, what do you think? Like when I have 100 users, okay, can I say it will be always 100 requests per second, or it might be one request per second also if there are 100 users?
Can you repeat the question? I'm sorry.
Yeah. So my question is, now let's say there are 100 users. Okay. Now, is it possible for 100 users to hit one request per second to achieve this throughput, or it will be above one, like it will be like 100 requests per second?
We can achieve it using pacing and depending on how much time
Yeah,
it
I'm not
takes. So
going to the technical side, like the pacing, think time, and all, but I'm speaking here logically. Okay, logically, is it possible?
yes,
Logically, it's not possible.
No.
Sometime it will go beyond 1 second also.
No, that is fine. What I'm saying here is, see, some might think, right? Like if you're 100 users, how can I hit one request in 1 second? It will go higher because 100 users are using it. And let's say I'm opening x.com. That is my request. Okay, I'm opening x.com. And when 100 users are opening x.com, there is only one open which happens in 1 second. So can it happen? That's my question. And when will it happen? Like why is it
That
happening?
in that case, actually, see, 100 users are going to at a time hit the server, then server will
Mhm.
be crash. So it won't happen
Yeah,
like.
so yeah, that's a good point. But yeah, but let's say our my server is able to handle it. Okay, there's no hardware issues there. So what basically I'm trying to say here is, now let's say to open x.com, okay, 1 second is a response time. Like a user takes 1 second. Okay, now if my application is good, 100 users will hit 100 requests per second if this is the case. If response time is 1 second. Now, what if response time is not 1 second? What if the response time is, let's say, 100 seconds? In that case, what will happen if your 100 users are trying to open your application? It might happen that you will be hitting only one request per second because it will take 100 seconds for 100 requests. Getting my point, all of you?
Vishnu, one question here. Am I audible?
Yeah. Yes, yes, go ahead.
As you said that 100 users, you are saying 100 seconds, but
Hmm.
you said that your application is handle 100 users.
Hmm.
After hitting all the users at a single attempt, is it take 100 seconds?
Correct. So that's what I'm saying, right? So 100 seconds or 1 second is the response time of your, let's say, okay, let me put it this way, okay, simple. For one user, okay, let's say there are two cases, okay, case A, case B. One user takes 1 second to open x.com, okay. One user takes 100 seconds to open x.com, okay. Now in an ideal situation, what I'm saying is if it's an ideal application, okay, if what will happen is if you have 100 users in case A, okay, now it's taking 1 second to open x.com, so your request will be 100 requests per second. This is very ideal case where your application doesn't, like, your hardware doesn't crash, or your hardware is able to scale as per the number of users, okay, that case. And here what will happen is for 100 user it will be almost one request per second. Because why it is one request per second here? Because in 100 seconds, how many requests? 100 requests. So if you divide 100 by 100, it will be one request per second. Getting my point, all of you? Just
yep.
try to imagine, okay? This is a very simple concept. but you might have some other thing going in your mind, maybe a wrong concept which is trying to block it. Okay, so think it's in that direction. So getting all of you? Any
In the
part
sense
which
for in the sense for all the 100 users, you are
Mhm.
calculating all the request time for all the users in a single attempt.
So it's
Is
not
it right?
it's not
100
that
users
way
for
actually.
100 seconds.
See, right, what happens is, see, 100 users are completing the whole transaction in 100 seconds. Okay, maybe some of the user would have completed in 20 seconds, maybe some of the user will complete in 150 seconds, some user will have, so average is 100 seconds. Take it
Okay,
that way.
okay,
Okay,
okay.
so in 100 second, 100 requests were completed. So if you do request per second, it will be one request per second. But here what is happening, in 1 second itself my application is performing, right? It's not 100 seconds. So in 1 second one user can open it. So 100 user can open it in 100 users will not take 100 seconds. They will also open it in 1 second only. Are you getting that? That's what I am trying to convey. That see, the more the number of user doesn't mean that it will get multiplied. So if it is 1 second, 100 into 1 second, no. Even 100 users also will take 1 second only. Are you getting, all of you?
In this case, then if one user will taking the 2 seconds, for 100
Hmm.
users it will take for 200 seconds.
No, no, no.
50
That's what I'm
seconds.
saying. It will not. It will not be like that. See, one user is taking 1 second. That means that is your response time of your application. Okay. Now, as a
Yes.
performance tester, this 1 second should be maintained for how many ever users you are planning, like 1,000 or 10,000 or whatever. So that is your objective. So if one user is taking 1 second, even 10,000 users also should take 1 second only to complete that transaction.
So this is
Ideal
the
case, I'm saying.
SLA. So this is the
Yeah,
SLA. 1 second is your
yeah, it's an
SLA, and
ideal
you have to
case,
maintain it.
right? It's an ideal case. So what I'm saying in the ideal case is, see, what happens is, though your number of users increase, okay, your system should be able to match that scaling, right? If it is one user or 100 user, it doesn't matter. The resources should be available so that all these 100 users should get that same resource which the one user is getting. So all 100 users, they are doing parallelly, right? They are not doing one after another. They are doing parallelly, all parallelly. So all of them will complete in 1 second. Clear, everyone? What do I mean by this?
Screen are not visible.
Oh, my screen is not visible.
No, yes, yes, now visible that.
Okay, yeah. So what I'm saying is,
Okay.
see, when I say 100 users, okay, let's assume there is one race happening, okay? A, B, one race is happening, A and B, okay? A is running to reach point D, B is also running to reach point D, okay? Now, A, like let's say, now again there is one race where A is going to B and B will go to D, okay? So here there are two users, here there is two users. Okay, now here it is taking, let's say, A to B 1 second and B to D 1 second. So total it is 2 seconds. So basically it is taking 2 seconds. But here A is taking, let's say, 1 second, B is taking 1 second. So will it be 2 seconds?
No, it is only
Good.
just, I guess, one
No,
second.
No,
It
it
will
is
be
no.
1 second.
directly redirected for
Average
D
1 second.
1 second.
Correct. It will be again 1 second only, right? So same is happening with this 100 users. What is happening now? This 100 users, all of them are starting together only. So all of
A
them,
and
this is
A
one
and B
second, this is one
requests are
second.
hitting at a time parallelly.
Correct, at a time, right? So all of them will finish that in 1 second. Now, if this is 100 second,
So when I
all of them
start the
will come.
when I execute the script, at a time parallelly when go hit the server
Correct.
and 100 users. Am I correct?
Right. Yes. Okay. So that, and now if this is 100, okay. Now if this is 100, these are 100, then it will become 100 seconds for 100. Now when 100 requests go in 100 seconds, how many requests per second?
One
How many?
request.
One request per second.
Correct. So that's what I'm saying,
One.
right? If you have 100 users also, sometimes your request can be one request per second also, that low for 100 users, because your response time is very high. It is 100 seconds. So now coming to the main point. So one is the throughput, which I have, right, which is in request per second, and one is the response time I have. Let's say it is in seconds. Okay. Now, if my response time is high, throughput will be low. Can I say that? Assuming all the like number of users is same. Okay, number of users is same. Number of users, let's say it is 100. If the response time is high, let's say it is 5 seconds response time, and throughput is, let's say, 10 requests per second. Okay. Now let's say response time is 1 second. What do you think? The request will be less than 10 or higher than 10?
Be higher than 10.
Correct. So it will be some, let's say, some 100 requests per second or something based on the application. Okay. I will not go to the correct count. So it will be higher. So if your response time is low, your throughput will increase. If your response time is high, your throughput will reduce. If considering your number of users are same for both the cases. Okay. Like here also 100 users, here also 100 users. Clear, everyone? Any doubts regarding this?
If
Okay.
the users
Now
are
coming,
not
yeah,
in the same condition,
which one? Sorry.
now we got that throughput and response. You are doing some comparison, right? For you
Mm-hmm.
constant users, if the users are
Yeah.
in different in both the cases,
No, users are same, but let's say your application, there is one application which is taking 1 second. There is one another application which is taking 5 second response time. For both the
okay.
application, user is same. Okay. Let's say y.com, this is y.com, this is x.com. Okay. Y.com, you will be able to hit 10 requests per second if because your response time is high. But x.com, you will be able to hit higher because your response time is low. But here one thing
Okay.
is there, your user is constant. See, so why I'm explaining you all this is there is a wrong notion that if you keep increasing the users, your request will also increase. No, it depends on your response time. Is that part clear?
Yes.
All of you?
Yes.
So if you keep increasing your users, it doesn't mean your request per second will also increase or your throughput will also increase. Your response time matters a lot. Now there is one vicious scenario here. Okay, let's say there is an application. If you increase the number of users, your response time is also increasing. It happens, okay, because we are not living in an ideal world where the response time will remain constant. More the number of users, the response time will increase, let's say. Okay, it is increasing, both are increasing. Okay, so let's say 100 users, response time 5 seconds, 1000 users, response time 50 seconds, and 10,000 users, let's say it is 500 seconds. What will be the throughput? So let's say here the throughput was something like 100. Okay, what will happen at this point? Will the throughput increase or reduce?
Reduce.
Reduced.
Reduce.
So let's say it comes
Reduced.
to 20. At this point, what will happen? It will come to 10. What is happening to throughput?
It's reducing, basically.
Yeah, but users, what you are doing?
Increasing.
Increasing.
See, are you able to visualize this scenario? Your application is not able to handle above 100 users, because as you keep increasing above 100 users, your throughput is dropping. So the maximum which my application could go is only till 100. Above that, how many ever users I add, they won't be able to visit, because my throughput will drop. So my performance will degrade. So that's importance of the combination of users, response time, and throughput. So these three parameters, all three together, is very important to analyze. We cannot divide these three. All these three have to be considered together. Is that part clear, all of you? Yeah. Any questions, anyone? Then I will go to the next.
Sorry, is there a maximum number of users for the response time to be 0?
No, it's not like that. So see what happens, no, whenever you have an application, that's a very good question actually. So if you have an application, okay, you keep adding the users, okay, at to some point it will keep increasing, the throughput will keep increasing. After a point, it will drop. So that's the maximum point to which, or the maximum users which your application can take. So this is a throughput graph, okay, which I have plotted. So this is the point above which we cannot go. Now what is happening here is your throughput will drop. That means your response time has increased to very high values, or your server has broke. It could happen both ways. Any like lot of conditions can happen. Okay, server broke, or your response time increases to a very high value, right? All of this can happen. Why the throughput will drop? So this is the maximum users at which your application can take. Now let's say Flipkart, it will be 1,000, for Amazon it will be 5,000, which they would have tested. Now my question to all of you is, from where will I get this number? So as a tester, right, I need some point, right, or I need some value which I want, which I have to test. Where will I get that value from? Like, okay, I have an application, it should minimum take this many users. So where will I get that data from? Who will give me that data?
From production.
From production, or I will use the most apt word, from the business, right?
Business analysts should be able to give.
Right, from the business, they will give me, okay, so I have Amazon.com, and Amazon.com, let's say it should handle 1,000 users. Okay, now they gave me 1,000 users. So this is called an SLA. We call it service level agreement, right? So they gave me 1,000 users. Now I will ask them the next question. Okay, you gave me 1,000 users, but in what time these 1,000 users should be able to do the requests or transactions? So they will give, okay, 5 seconds, or to make it easy, let's make it 1 second. So this is also an SLA. So I got the number of users, I got the SLA of 1 second, right? So in 1 second, these 1,000 users, if my application, there are 1,000 users who are using that application, they should be able to access the application in 1 second, though there are 1,000 users who are using it. So that's the SLA. Now when, let's say, the application is there and I am testing it, do you think it will be 1 second when I am testing it?
Uh,
It can be 2 seconds, or it can be 0.5 seconds, or it can be 1 second. Anything can be, right, when I'm testing it. Now if it is 0.5 seconds, is it good or bad?
It's good. It's
It
good.
is good. As a performance tester, I don't have anything much to do here because it's already performing very well. Okay. If it is 1 second, pretty good. Okay, because it is at the border. Okay, it's good. Still, it's fine. But what if 2 seconds? Is it good or bad?
Bad response.
Bad response.
Bad.
So, as per performance is concerned, it is a failure. 2 seconds is a failure because our SLA is 1 second and we are getting 2 seconds when we tested. So now what's the next step for if it's a failure? What do you think is the next step?
You have to find the bottlenecks.
Correct. So see, now this 2 second is coming, right? This 2 second is coming due to what? So if I have an application, let's say if I open some application, like let's say let's pick up some Amazon, okay? Since we're speaking about Amazon. Now if I go here and if I just try to inspect the element once, if I go to the network and I reload it once, okay? Now if you see here, this is a waterfall which it is showing, okay? Now see, totally the response it took for this application, for this request, okay, if you see, if I go to this, see it took around 1 second, right? And in that 1 second, are you seeing lot of different components like request send, waiting for server response, content download? So there are different steps. Now out of these steps, which one took more time?
Download time.
Content download, right? The content download took 800 milliseconds. Okay, now let's say my customer has given me an SLA of 500 milliseconds. Now this is a failure because it is giving me 1 second, right? So I have to bring it below 500 milliseconds. Now if I have to bring it below 500 milliseconds, what I will guide the developers or the development team is to bring down this content download time. It is 800 milliseconds, bring it down to 300 or 200 milliseconds so that the total will come below 500 milliseconds. This is a very vague way of saying, okay, very high level way I'm saying, okay. There is deeper ways to give this thing, like what you need to improve or what has to be improved, but this is one starting point I'm saying, okay. So you need to give, okay, improve this time. So content download, then what they do, they look for the content download. Maybe the images are very heavy, they will reduce the image size so that that response time comes down. And then what we do, we again test. When we test second time, okay, if the fix is done, what will happen? This 2 second would have come down to, let's say, 0.8 second. Then we have fixed the issue. As a performance tester, it's a win for us, right? All of you?
Vishnu, can you go to that request, please? That Amazon network tab you will shown
Yeah,
just before.
yeah, this one.
Yeah, it is totally taking the for that particular page or particular URL. It is taking how much time?
No, here we are speaking about this request,
Only
this
one request. Only
www.
one request, right?
One request, correct. The total is
Okay,
here.
okay, fine.
Okay,
2.68.
yeah,
Yes. Yeah.
correct, correct. Yes. Okay. And now coming back to our thing. Now this is one win. Now the second win, right? This is one win. What if I can save some money for my customer? So this is okay. He has given me an SLA. I am fixing the SLA. I am bringing down the response time to that much time. It's a good thing, right? As a tester, my first win is done. The second win is uh, like if you can save some money for your customer, right? Now where that money goes, right? That we need to see. Where do you think the money goes of your customer in your application, which you can save? Okay, let's assume there is an x.com. Okay, there's an x.com. Before I go to x.com, let's say there is one 5 kg block. Okay, and pulling it, and let's say it takes some A force. It's not a physics class, so just I want to make an analogy, okay. So there is one another B force, okay, for 25 kg. Which do you think, which force will be higher, B or A?
Will be higher.
B will be higher, right? The force required to pull pull 25 kg will be higher, right? So same is the case with the softwares also, right? More heavy your software is. When I say heavy in terms of code or maybe images, okay, however way, okay. If the software is heavy, more CPU, RAM, and those resources, those hardware resources will be required. More heavy your software, more CPU, RAM, and these things will be required. And do you think the CPU, RAM, is it free or you have to pay for this? See, wherever this software is running, right, your application or your Amazon.com, whatever your code is there, where it is running in a CPU somewhere, right, in cloud or somewhere. So for
In the
that, you
cloud,
have
we
to
need to
pay,
pay.
right? Not only cloud, anywhere. Even if it's your house, also you have to pay because it's a CPU. So if you have to pay for the Wi-Fi, you have to pay for the power, right? For running that CPU. Those CPU, again, for CPU also you have paid. You have bought that CPU, right? So it's not free. Resource is not free, right? So now let's say 100 users require one CPU. Okay. Do you think 10,000 users also will work with this one CPU?
Yes.
No.
No. You
No.
might go. You might
No.
have
Depend
to
on
go
the
to
No.
10.
size.
You might have to go to 10, right? So what is happening? If it was one rupee here, it has become 10 rupees. The cost 10 times, right? Now, as a performance tester, how can I reduce this 10 rupees? What is it that I can reduce? Like, or what is it that I can optimize? Coming back to that 5 kg and 25 kg. So what is that thing which is heavy, which I can
We
make it
have to,
light?
excuse me, sir.
Yeah, good.
We have to distribute the load.
Uh, so that is all technical side. Here we are purely speaking logical side. Okay. So my software code, which is, let's say, okay, if I want to bring down this 10 rupees, the software code which is there, right? I have to make it light. Lighter my code will be, the cost will come down accordingly, right? So lighter my software will be, or lighter the code will be, my cost will come down. The CPU will become from 1 to 10 to 1 to, let's say, 5 or 6. So I saved
Vish-
4 rupees.
Vishnu sir, I have one doubt.
Yeah. Go ahead.
How to find 100 users suitable for one CPU?
So what's your question? Like 100 users, whether it will take one CPU, how we will find, is
Yeah.
it?
Yes.
Yeah. So that's where the performance testing comes, right? So see, one side of performance testing was the response time, right? Which we saw. The second side of the performance testing is the resources. So you have to optimize the resources, the CPU, RAM. So for that you run the tests, right? For 100 users, it took one CPU. 1,000 users, it is taking 10 CPU,
Okay.
right? Now, how do you know whether 1,000 users take 10 CPU? Because when you have 5 CPU, okay, let's take it this way. Can someone go on mute like this? I'm getting some noise. I don't know who, but yeah. Okay, thank you. Right. So see, now there are 100 users, okay? And 100 users are take like 100 users, my application is running smoothly with one CPU. Response time is coming 1 second. Okay. Now when I went to, let's say, 200 users, one CPU, what I observe is my response time went to 5 seconds. So what I will do? Now I have to bring down this 5 seconds. What I have to do for that?
Optimize the code.
So
Either
increase the
optimize the
CPU
code. So two ways. One is optimize the code or increase the
or
resource.
increase the CPU.
Yeah, increase the
We
resource.
need to correct. We need
Right.
to increase
Now,
the
busy.
CPU size.
So as a performance tester, will you give this as a solution or this one? First one.
First one, optimize code.
First one. First
Correct.
one.
Because the second one you will never give, because if you give second one, then why have they kept you for the job, right? Because they are paying for that extra CPU also, and they are paying to you also. So that's not a optimum solution, right? The solution is here, optimize the code. Now, if there is a case where whatever you do, the code is not getting optimized, like, okay, whatever you do, it is like there is no way. The only way is to increase the resource, right? So what do? You increase the resource. So you make it 2 CPU. Now the response time will come back to 1 second. So this way, what you do is you will check for 1000 users the number of CPU required to maintain that 1 second. So let's say it is 10 CPU. Okay, so you have maintained it at 1 second. Now the next step comes. Next step is even reducing this 10 CPU. So what I do, I optimize my code further. I profile my code further so that this 10 CPU, right? Whatever 10 CPU is there, the software will become lighter, and this 10 CPU will come down to 9 CPU, 8 CPU. So even 2 CPU, if it is saved, you are saving money for your client, and they will be happy. Clear, all of you? So as a performance tester, there are two ways you can show your visibility. One is by reducing or optimizing the code to achieve the SLA, whatever your customer has given, or your client has given, or your business has given. The second way is to optimize your resources, the CPU, RAM, whatever the infrastructure is there, right? By reducing it down so that they save money. And obviously now, let's say you are saving, and what do you think the generally the money spent on infrastructure? If there is an application like Amazon, what do you think, how much money they would be spending on the CPU, RAM, these things per year, let's say? What do you think that
A
amount
lot.
will be?
A lot.
Still some number. What do you think?
I mean, Amazon, they might be using the cloud services, AWS,
Mm,
so which is obviously subscription based. So, but yeah, still
mm-hmm.
hundreds of
Yeah,
thousands of dollars.
can I say millions of dollars?
Yes, maybe. Yeah.
It will be, okay, it will be in millions of dollars, okay, in a year. Now, if now this millions of dollars, if I divide it per day, okay, per day basis, let's say per day, let's say they are spending $1 million, okay, which is very low actually. For Amazon it is higher. Okay, let's say per day they are spending $1 million for 20 CPUs, or like say 200 CPUs. So what do? You optimize the code and bring down that 200 CPUs to, let's say, 180 CPU. So percentage wise, you have improved 10%. So you have saved 10% of 1 million. So some 0.1 million, okay, into 365 days, which is a very huge amount, right? Now, when you have saved this much for them, do you think they will be worried about your what they are paying for you? Anyone?
No.
No, right? So this is where the real value lies in performance testing. Because if you are very good at that, good at performance testing, you will be directly saving money for your customer or client. And if you are saving directly money for them, why will they hesitate to pay for you? Hello, all of you?
Yeah, right.
Everyone agrees? I
Yes.
hope.
Yep, got it.
Yes.
Yes.
Right? Right. So that is one advantage which every performance tester has, that they can reduce the cost very directly compared to other, like let's say if you take development or if you take functional testing, saving money through functional testing or development might not be direct. They will have to take some indirect paths. They have to think about it, a lot of things. But as a performance tester, right, your path is very direct to save money. This is the number of resource, reduce the number of resource by optimizing the whatever things you have. It's not always only the code, even optimizing the architecture or code, or and for that optimization also, what do you think? Do you do the optimization or others will do the optimization? What do you think?
Mostly the developers and the architects, like,
Correct. So that is also a plus point, right? Because we are just giving recommendations. We are the people who give recommendations. Recommendations means, okay, you improve this, you improve that, this is the problem, that is a problem, but they will solve it, they will optimize it, right? But if you see the name, who will get? We will get, because we are the people who found out the problem, and we are the people who help them to solve it and bring down the cost. So that's a very big plus point, right? Right. So this is how the performance testing is very critical for most of the organizations, and especially those organizations who spend a lot on infrastructure, lot on infra. So when I say spend a lot on infra, either the business, the number of users will be so many, like take some e-commerce platforms, social media platforms, or logistics, retail, any domain, okay, any domain where the number of users are high who are using the application. Now, what if the number of users using the application is low? Will performance testing have any impact on that?
Can you repeat the
So
question?
let's say there is one application of leave approval. Okay, that application is for approving leave. Okay,
Okay.
and I have seen most of the time this application is slow for all the organizations. Maybe they don't
Right.
want us to take leave. Okay, I don't know. But what I'm saying is, will you be doing
Mhm.
performance testing on an application like leave approval?
You can, and you can do
We
it, and
can, but
yeah,
do we? Do we?
it depends. Like if
Most.
it is an something, the
Mhm,
scenario is single sign-on,
mhm. So most of the
then
time it's no.
yeah,
Now why it is no? Because see, now if you take the leave approval application, okay, let's say there is a company with 2 lakh employees. Out of the 2 lakh employees, let's say, do you think all these 2 lakh will log into leave approval daily?
No.
No.
No,
No.
maybe some thousand might go to this leave approval. Okay, but take the same case. Let's say there is an application of maybe login. Okay, means like if they log in, then only they will be able to start the work. Okay, what about this one? How many users will be logging in?
200,000.
2 lakh, let's
Everyone.
say, daily. Okay, so out of these two applications, here there are 1,000 users, here there is 2 lakh users. Will you be performance testing this application or this application?
The login application.
Login, right? We will not test this because it is just 1,000 users, and if you see the percentage wise, it is not even like it's very low, right? Maybe 0.5 percentage of the total user count what you have. So such type of applications basically fall under admin apps and all. So we generally don't do performance testing on such applications. Our applications will be those, like we will choose the applications based on the number of users of the business who will be accessing that application, and it has to be uh, high, comparatively high. Now how much high, right? How much high means at least of the total number of users, 10% of users should be using that application. This is the rule of thumb which I use. Okay, so now for this leave approval, okay, this leave approval, out of 2 lakh, let's say if 20,000 users were using it, I would go for performance testing. Otherwise, I will not consider it for performance testing according to the entry criteria or acceptance criteria, or whether we can take it for performance testing or not. Because the reason behind that is two. One is you won't be adding much value to that, because you'll be just like a validation, what you will be doing, just validation. You won't be adding much value to that. Second is the load is also too low compared to this 2 lakh load. Obviously, your application infrastructure is hosted both on the same infrastructure, right? If login is able to take that much, obviously leave approval will could be able to take this 1000 load, which is very low, right? Now these are the conditions. Now if there are some exceptional cases where okay the application is loading very slow, or it is a very critical application, okay, in those cases you can take it up. But let's say if you have 10 applications to test and you have to take only 5 applications as per your timeline and bandwidth and all, then you check these things before accepting or before choosing the application, which one to go with. Okay, now coming to the main thing. Now to just wrap it up, so performance testing is all about load and stability. How stable your application is under a specific load or under a load. Now load, how do you understand the load? From the throughput. I will put load as response time. I'll explain you why, and stability as throughput. Okay. Now, when I say load as response time, what is happening if the number of users increase?
Response time will go high.
Correct. So based on the load, the response time will fluctuate. Now, based on the stability, what will fluctuate?
Yeah.
Throughput will fluctuate. So the whole performance testing in terms of KPI, right? These two are very important: response time and throughput. That is nothing but load and the stability. So if your throughput and response time both are under SLA means like whatever your customer has given, that SLA is achieved, then your application is performance wise, it is certified, or yeah, you can certify that performance wise the application is performing well. Right, any questions anyone? Let's take up questions now.
Hi, I
Yeah,
have a
right.
nonsense questions.
No, that is totally fine. Question is question, and I like
um,
nonsense questions. Okay. Yeah,
when you
good.
say
Yeah.
throughput, does
Mm-hmm.
it mean that the request plus response time, or because when I send a request, let's say I want to open x.com, I just
Mm-hmm.
go to the browser and type x.com.
Uh-huh.
And that is the I guess that is the request,
Mm-hmm.
and when I get the page in my
Mm-hmm.
screen, that is a I got the page. That means like I got the response.
Mm-hmm.
So
Correct.
throughput is the altogether the time, or the data, you mean like I'm sending some data and getting some data, so that is the
Okay.
throughput.
So let me put it very simple way. So see, now let's say there is an x.com, okay, which you are trying to open. Okay. Now, I have a clock also which is running side. Okay, just to assume. Now I am trying. Let's say x.com is taking 1 second response time. Okay, like x.com generally, let's say it takes 1 second to open fully. Okay,
Mhm.
and it takes 5 seconds to open. Let's say y.com takes 5 seconds to open. Okay, now let's say I keep after 1 second I again load. Okay, I do it 10 times. So how many seconds? Let's say 10 seconds. Okay, I keep doing it every second. In 10 seconds, how many requests? 1, 2, 3, 10 requests. So in 1 second, how many requests I am sending?
One request.
One request. Okay. Now take this case. Same thing I am doing. 5 seconds. Again I hit. So I am doing it 10 times. Okay. So 5 seconds, 5 seconds, 5 seconds, 5 seconds, 5 seconds. So total 50 seconds. And how many? 1, 2, 3, 10 requests. Now, what is the how many requests I am able to send in 1 second?
How many requests? One request, 5 seconds.
So see, one request takes 5 seconds, right?
Yeah.
So in my request per second, right, it will be 10 by 50,
5 seconds.
which will be 1 by 5.
Each one request
So
it takes 5 seconds.
correct. So the request per second is this. Are you getting now? And this is the throughput, this request per second.
Can you repeat again what you said? I missed the last portion.
Yeah. So see, now the first one, it is taking 10 seconds for 10 requests, right? 1, 1, 1, 1, 1. So basically what my server is seeing one request per second. Similarly, here what is happening? My request is taking 5 seconds, right? The response time is 5 seconds. So if I keep hitting 10 times, it will take 50 seconds for 10 requests. So here my throughput will be 1 by 5 requests per second. So all of you, my question is, which has higher throughput? This one or this one? The throughput is high in the 1
First
second
one,
case, right?
first one.
First one, right? Here the throughput will be low because your response time is high. Whatever you do, your site is coming up only in 5 seconds. Now, let's say, if I have to, I want to increase the throughput. Okay. If I want to make it one request per second for this one, what should I do? I will
You
increase the
should bring
users.
down response time.
I will increase the users, right? Currently it is
Increase
for
users.
one user. I will run it with like 10 users. So my throughput will be one request per second. But the problem is that one request per second I am getting from 10 users, okay? Not from one user. So if the same 10 user I apply here, it will become 10 requests per second. Okay, so okay, let me rephrase this question. Is throughput clear to all of you? Anyone has any doubt in throughput? What's a throughput?
Yes, it's clear.
Right?
Request per second.
Request
Correct.
per
Request per
overtime.
second
I mean,
over
it could
time.
be,
Yes.
yeah, it could
It
be
can
an
be per
hour or a
minute.
minute. Yeah.
Correct. It can be per hour. It can be per minute. It can be per second. Per second, we generally call. There is one word called transaction. I will explain you what it is. This TPS word is very common. Okay. If someone asks you what is TPS, it is nothing but similar to request per second or transaction per second. Similarly, you have
Target per
TPM, transactions
target per
per
second.
minute. Not target, it is transaction. Okay, and transactions per hour, all of these are equivalent to request per hour, request per minute, okay, or request per second. So all these are throughput only, nothing but all are same. Okay, so performance testing is nothing but load and stability. And load, direct KPI metric is response time. Stability, directly the metric is throughput. And based on the different analysis, graph, different tests and all, whatever we do, right, we achieve those things. That we will see. How you create the test, what all tests you run, how you find the bottlenecks, how you optimize things, how you save money for the organization, right? Ultimately. So that's what we will learn in the due course. Yeah. Any questions, anyone?
What if SLAs are not given?
Right. That's a very good question. Okay. And it's an interview question also. Maybe you would have attended one interview also. Just right. Okay. So if you don't have an SLA, right, that's where the planning stage comes and your experience comes into picture. That I will explain you. Okay. When we go to the planning stage, when we discuss about planning, creating a test plan, test strategy, That time I will explain you how to go ahead with that.
Vishnu, just as a theoretical, can you tell something about it?
Yeah, it's basically, see, you need to have little bit of understanding of few more jargons, okay, before I can jump into that. But mainly you have to analyze the production data and previous applications which you have worked on, right? And you have to put the SLA in front of the customer. And how you do that? What are the tips and tricks for those? That I will explain you when we go to the planning stage. Now the time will not be, means it will be a very high jump, and time will be also sufficient for that.
Vishnu sir.
Yeah, go
Vishnu?
ahead. Yeah, yeah, sure, no
Yeah.
worry. Go ahead.
As you said, I have executed one API. I mean, one
Yeah.
request. So
Mm-hmm.
one of my requests is taking total 253.16 milliseconds,
Okay.
and waiting for server response is getting 94.38 milliseconds, taking more time.
Mm-hmm.
How to resolve the issue? Waiting for
No, no. So repeat your question once.
waiting for server response is taking more time, 94.38 milliseconds.
Mm-hmm.
Okay.
Yeah.
How
Mm-hmm.
to how to resolve this issue, this particular
Mm.
issue?
So see, Gopi. Now the question here is, it's more sort of saying like, okay, I have a vehicle. It is stopping at every 1 kilometer. How to resolve it? Now you have to give me what's the vehicle, right? What is it built of?
Okay.
What is the engine CC?
Okay.
How much fuel you had, right? So those things you have to
Okay.
analyze, right? Those things you have to
Yeah.
analyze, and you have to see where is that waiting happening,
Okay.
right? That waiting time is nothing but your request is getting blocked somewhere. So you have to find out where that block is happening. And for that only your AppDynamics, Grafana, those tools will help you.
Okay.
Okay, that's what we will be seeing in this course, like how you will use those tools to find out that problematic areas,
Okay.
right?
Sir,
Yeah, go ahead.
what is root cause analysis?
You just say me what is root cause analysis from the word what you understood.
Where the problem we have to find.
Find the problem and
So root cause analysis is nothing but simple. Okay, you found a problem, so you have to keep going to the root of the problem. Like you keep going digging, and you go to the real cause of that problem. Not that you just see, okay, it is caused by this, and just resolve that. No, you have to go beyond that, because if you see a software architecture, it will be layer by layer, right? One after another, one after another. So which layer is the real problem? That is nothing but the root cause analysis. Yeah. Any other questions, anyone? Swati and others, anyone? Any questions?
Yeah, I have one question. In terms
Yeah.
of you said TPS, TPH, everything the same, right? So hits per second is also same, right? Like throughput on, right? Hits per second.
Correct. Yes. Response time always generally we speak in seconds only. We won't be speaking in hour, minutes and all. It will be always same. Yes.
No, no, I'm
For an
saying
application.
hits. I'm saying hits per second. Hits.
Mhm. Hits per second. Yeah, that's what. So we will discuss this. There is a small change between transaction hits and request. Okay, which we will discuss. Generally, it's more sort of like you can say generally request per second can be transactions per second, but this transactions per second, right? It's not always. Yeah, that's what. So it's a little complicated, which I will explain you. When we speak about APIs, right? It is very easy. But when we speak about web services, it becomes little complicated. So that I will explain you. Oh, there's a small variation, okay, between
Okay.
these. Yeah, yeah.
Uh,
Thank you, Swati.
One more question. So in this
Sure,
course,
go
you
ahead, go
cover
ahead.
in the course you cover more of the JMeter, or you cover like APM tools, or like which one you cover more deep?
Yeah. So JMeter is obviously the tool which we are taking. So if you
Okay.
say, let's say 40 hours is the course, okay? So let's say JMeter we will be taking around, it will be a good portion of time. So maybe I can consider 50 percentage of time. Okay. Performance testing concept, those things will take, let's say 20%, 25% of the remaining time. Then we have our monitoring, analysis, recommendation, reporting, and all those stuff, the remaining time.
Is JMeter the usually the tool that that companies want you to use?
Yeah, so that's a very good question, Glassman. So the thing is, JMeter is a tool, even developers use that. Not only our performance testing use that, even JMeter is used by the development guys also to do some unit tests. Okay, so it's a very widely used tool, not only by performance testing, even developers, even functional testers also sometimes use this tool to send some requests, to do some small unit tests and all. It's a very widely used tool. Okay,
Thank you.
yeah.
So JMeter, you go a little bit deep or like just a high level only?
I will say pretty deep, okay? Because
Okay.
whatever knowledge, even the working professionals who are into JMeter, they might be not knowing many things, okay? Because they would be working only the concept which a project requires, right? But JMeter is far beyond that. So that's what we will see in this course.
So so in this
Yeah.
one, you cover the BlazeMeter also, or only JMeter? Because BlazeMeter is also similar like JMeter, right, on the cloud.
Right, right. Blaze meter we will cover, but it will be, I won't say it will be very detailed way, but in a high level way.
Okay.
Yeah. So basically, for those, I think yesterday who didn't join, to just call it out again. All right, we have JMeter, we have AppDynamics, we have Grafana, we have Prometheus, and in the infrastructure side, we will be seeing Kubernetes, Docker, containers. Okay, how you analyze, how you debug things, and on the performance testing side, obviously planning the test plan, test strategy, those things will come. So this is what we are covering. Out of this, JMeter we will be covering extensively because that's a performance testing tool, right? You have to know that tool extensively to use it. So that's what we'll see. And in the analysis and recommendation, those section, we will see the infrastructure, monitoring tools and all. And the final
What is
part is
workload?
more sort of for, as I said, it's like not for all, where we cover the Jenkins, right? The CI/CD, which will be like just 1 hour of the final session, where we will understand how you integrate JMeter with Jenkins in the CI/CD pipeline.
So, I have a question here. So
Yeah,
would you
sure.
be giving us interview questions like scenario based, like how do you do that, and what kind of uh, interview questions will be
Yeah.
covered, something like that,
Yeah, obviously.
solely
So
based
what
on Jim.
happens, right? What my generally my teaching style is in such a way that when I conduct the sessions itself, in the ongoing sessions, I bring up the questions, okay? And if you cover those questions itself, your interview will be 90% clear. Okay, and I make sure that because rather than, and even we can, if you insist, like we have a session specifically for discussing questions, right? Even I can conduct that even after the course also, just 1 hour with all of the students of my batch, maybe.
Uh,
So
and
yeah,
also the
we will
course
surely
will be
discuss.
like more like a practical, like, or just you go on the theory ways only.
So can you repeat another once more?
No, the course will be like more practical, like showing how to do
Correct,
in
correct. So
JMeter.
theory is very low actually. So
Okay.
theory is only the initial part of performance testing and all, right? Then we totally get into JMeter, Kubernetes, Docker, container, AppDynamics, Prometheus, Grafana, CI/CD. So we just go that way.
Yeah,
So
because we are
theoretical
looking
part
for
is
more
very low.
practical. Yeah, looking for more practical and real time. Yeah.
Correct, correct. So because see, if theory also, I don't have much time here. Like it's just 40 hours course. Frankly, 40 hours is not that high. Okay, it will go like anything. So theory, I don't have much time. Morely, it will, most of the things will be hands-on only.
Okay.
Yeah.
Hello.
Yeah. Hi, Rekha.
Yeah, hi. Actually, hi Vishnu. So sorry for the late reply. I'm having some network issues. So,
Yeah.
coming to my point, see, I have around 11 years of experience in the throat-ended testing field only. So it is a combination of a functional testing and as well as automation like
Mhm.
UI and API testing as well.
Yeah.
Now, I want to explore my knowledge with the through performance testing level only. So I don't have any experience about the performance testing. So as your lecturer only, I come to know how the performance test will goes. So
Yeah.
my question is after completing the course, how I can how much the percentage I'm able to do the performance testing level.
Mhm. Yeah, so
So
see, Rekha, so that's a very good question. So when you speak about performance testing, especially those who are in the experience range above 8 years, okay, let's say, you should be good at performance testing and also performance engineering. Okay. Now, when we speak about performance testing as such, I will say 99 or 95% of things you will learn in this course. But if you speak about the performance engineering side, which is expected with the higher level experience guys, okay, better to take some small course on performance engineering before you attend any interviews and all. It's a good thing to do that. But performance testing as such, you will be totally done with this course. Only thing is you will have to do little hands-on, a little bit practice after the sessions are done daily, right? If you keep up with those, you will be totally from zero. You will reach to 90, 80 levels, 90 levels, and then you need to practice with different applications. You will. It's very simple to understand because why it is happening is I am going to give you a lot of pre-made things, right? Which will help you. Like for example, test plan, test strategy, documents, scripts, then also and some tips and tricks which you learn with experience, right? So those things you will get. Then it will be simple for you to catch up.
Sure. Thank you,
Yeah,
Vishnu, for clarifying this. Just I
yeah.
want to know one more thing also. Is this different for the performance testing and performance engineering? So,
No,
or
no,
else
no. See,
both are
domain
same.
is
See,
same. Domain is same. See, the person who hasn't completed performance testing, he cannot go to performance engineering. It's little advanced concept, right? So first initial years of your experience will be in performance testing only, like 6, 7, 8 years. Okay. Then you move on to performance engineering, and performance engineering is more like it's not a necessity, but it is just a requirement. Okay. If you have it, it's good. Because since you are into 11 years, 10 years experience range, right?
correct.
Yeah.
What kind of
Means
courses are recommended for performance engineering?
Only one course, performance engineering. That's all.
Okay.
See, there
so perf
it is more sort of like there what happens, right? There you go little deeper into the code and all, little heavy on the coding side. Okay, performance testing is not that heavy on the coding side. Here you don't have much to much to do on the coding and all. But in performance engineering, it is not that case. You will have to know little bit of coding and all.
means just I want to know, Vishnu. So for the performance engineering means what are the tools and techniques we need to use for
So
that?
see there you will come across different tools like again AppDynamics will be there. Okay, AppDynamics these things will be obviously there. Even JMeter these things will be there. It will repeat. Only thing is there you go and look into the code and optimize the code.
Okay, got it. Means
Uh,
it is a bit advanced techniques, right? We need to.
Correct. Yes, bit advanced. So there what happens is you don't say developer to fix it. You say you give the developer okay change this more sort of that way,
Okay, got it.
right?
Yeah.
Yeah.
Thank you, Vishnu. Thank you very much.
What are the applications you are going to cover in this programs?
Yeah, so obviously there are 3, 4 applications, but mainly I will be using. Yesterday I showed, I guess there is one microservice based application which is on a Kubernetes cluster, okay, which we will use to test our test using our JMeter, and we will try to test it, create scenarios, end-to-end test and all on that application. It's an e-commerce application which we have. Yes.
If we
One last question,
practice,
Yeah. Yeah.
uh,
Go ahead.
you said you cover AppDynamics, all this integration, right? Do you cover anything on Datadog as well?
No, no, no. Sorry for that, because whatever tools I mentioned, I might not go beyond that, because if time is there, I will be happy to do that. But I don't know whether I will be able to do that in this
Uh,
short span.
yeah, because right now the market, there's a lot of demand for Datadog and a lot of companies are
Mhm.
asking. So
Yeah,
that's the
but
reason
it
if
will
you
be
can.
very easy for you. If you learn one, the other one it will not be very different. If you see, if you know one, like let's say if you know Grafana, the other monitoring tools are also similar. So it won't be a very big deal to learn those things.
So you'll show that how to install the agents, everything, right?
Correct, correct. Yes. Yeah, Gopi, you had some question?
No.
Okay, right. Actually, I wanted to show JMeter today, but time is already, but that's fine, because generally it happens due to interactions and all. As I said, now the course is 40-hour course. Sometimes it might go to even 40 to 44 hours and all because of the interactions. That is fine. Uh, but anyway, so it's almost 10:23. Sorry, we are shooting little ahead of time. Sorry for those who already have some meetings and all. I can quickly take some one or two questions and then we can stop. Anyone? Any questions, or let's stop it here for today?
I'm good, thank you.
Yeah,
No
fine.
questions.
Okay. So let's stop it here for today. Tomorrow we will continue with the topic, and we will soon start with JMeter, and we will see how the JMeter dashboard and a basic script we will record tomorrow in JMeter to understand how the scripting happens, and some one small performance test we will run using JMeter. Okay. Yeah. Thank you all, and have a good day. Meet you all tomorrow. Thank you.
Thank you, Vishnu.
Thank
Thank
you.
you.
Thank you, Vishnu.
Thank you, Vishnu.
Thank